In the last video, we discussed about how do we find out the confidence interval for the population mean when the population standard deviation is given. Okay, so confidence interval for mean, population mean when the population standard deviation is given. Okay, what was the formula? The formula was x bar minus mu the formula was x bar minus g alpha half, right? So g alpha half times sigma over root n, that is the lower bound or the lower limit of the confidence interval, and then upper limit is x bar plus the same thing, g alpha half times sigma over root n. That was the formula we did. Okay, so the examples we did had all the sigma n and x bar given. So we found g alpha half based on what percent of the confidence interval was asked. So the statistic was given, but in this example the data is given. Okay, so data is given. So how many data are given? There are 30 data are given. Sigma is also given. The population standard deviation is given. So what is not given here is, so this is n, right? N is given, sigma is given. What is not given is x bar. So x bar not given, right? So we need to find out x bar first. So how do I find out x bar? Is what you do is go to the, you use calculator and you enter this data in your calculator. Okay, let me go to the data. So go to the stat and then there is edit, hit enter. Okay, and then I enter all these data. I enter 43 and then enter 52 and then hit enter 18, hit enter 20 and then hit press enter 25, press enter 45 and so on. Okay, after you enter the data, since our goal is to find out x bar, the sample mean, and we want to estimate the confidence interval for population mean. Okay, so we need to find out the sample mean first. Let's find out the sample mean. So after you enter the data, what you do is stat and go to calc. Okay, and it picks the one variable status automatically. Hit enter and the list, the data is in L1, the frequency list, there is no frequency, and calculate. Okay, so if you calculate that, you will get x bar is 32.03. okay, so we found x bar is, so from the data you found x bar is 32.03. that's what we found. Okay, so now we have almost everything. Okay, we have the mean, the sample mean, we have the sigma is given, we have the n is 30. That's what we need, mean and sigma and then n. What we need to find out next is g alpha half. Okay, so how do I find out the g alpha half then? So to find out the g alpha half, so it is basically what percent, 95% confidence interval means the middle region is 95%, right? So the middle area is 0.95. So what will be the outside area? The total outside area is 5%, right? 0.05 is the total outside area is the 5%. Okay, now so since the total outside area is 5%, then we need to divide that into the two halves, right? Because there are two outside areas there, so you need to divide that into the two halves. So how do we do that? Is you need to divide the 0. Let me write down here, 0.5 divided by 2 will be 0.025. so this is 0.025, right? And then this is also 0.025. Now we need to find out g alpha half, negative here and negative g alpha half. So 0 is in the middle. Okay, so how do I find out negative g alpha half? So negative g alpha half is, we need to use inverse norm, right? Inverse norm, and what is the area left is 0.025, 0.025 and then 0.1. Okay, let us use calculator to do that. So the calculator shows that, let me clear this and then go to the second verse and then inverse norm number 3, hit enter, and what is the area? 0.0, so that will be 0.025, 0.025, mean is 0, sigma is 1, and then paste it. You get negative 1.96, right? If you um, if you write that into the two decimals, if you round up to the two decimal, negative, so negative 1.96. So that negative g alpha, what is the value of g alpha half? Then it is 1.96 positive, right? Now you use that formula to find out the confidence interval. How do I do that? Is x bar minus g alpha half sigma over root n and comma x bar plus g alpha half times sigma over root n. Okay, so how much is x bar? So the x bar here is basically, x bar is 32.03 minus 1.96. Sigma is given as 11 over root under 30, and similarly 32.03 plus 1.96 times 11 over root under 30. That's what you see. Okay, so if you use calculator for that, let me use calculator just and then get the values there. Okay, so here what we have is basically 32.03 minus 1.96. So 32.03 minus 1.96 times 11 over, so 11 over 11 divided by square root of 30. That's what you do. So if you hit enter, you'll get 28.09. Okay, so the left bound is basically 28.09, and to find out the right bound, exactly the same thing with plus sign, right? How do I do that? Type exactly the same thing with plus sign, second, and then enter, copy that, and then go back to the minus sign and change that to plus. Okay, if you do that, you will get, what you get is basically hit enter, hit enter, so you get 35.97. okay, so that will be 35.97. In your online homework, you will see like this. Okay, you will see in your online homework, it gives you this value as 28.09 is less than mu, population mean is less than 35.97. This is what you will see in your, this is what you will have to, this is how you will have to enter in your online homework. Okay, so this is by hand, we did everything by hand, but we use calculator to find out this g value. Now we can do this whole problem by using calculator directly. Okay, so how do we do that? Let me go to the calculator, let me clear what I have. The first thing you do is you always enter your data. So we have entered that data already. Now after you do that, you do basically stat and then go to the test. Okay, under the test you need to go to the g interval, exactly the same way, but the thing different here is previously we needed the stat because statistic was given, because the sample mean was given there, but now we need to pick the data. Okay, because we have the data given, the stat is not given, we have the data given. So what is sigma? Sigma is 11. Okay, and then what is the list? Where is the data? Data is in L1. We enter the data in L1. Frequency is 1 because there is no frequency, so we write 1. What is the confidence level? Is 0.95 because it is 95% confidence. And if you hit calculate and then press enter, you get 28.097 through 35.97. You got exactly the same value if you do that directly using calculator. Again, this g interval was used to find out the confidence interval for mean when sigma is given. When sigma is not given, we will use t interval. That is the next thing we will be doing. Okay, for now we use the g interval. Okay, so how do I use calculator? The thing is given here too. All right, and select data, stat, test, g interval, and select data. Then enter the information for sigma, list, that is, and then n, and then c interval, the confidence level also you need to, and then do the calculate. Okay, that's what you do. All right, so I want to do example number 5 using the calculator directly. Okay, so how do I do that? Let me list the given thing first. In a recent study of 35 9th grade students, so n is 35, the mean number of hours per week that they played video game is 16.6 x bar. How do I know that it is sample mean? Because it talk about the sample size and then they said the mean of that sample is 16.6. So 16.6. The standard deviation of the population, this is sigma, right? Because it says population standard deviation. Sigma is given as 2.8. Now find the best point estimate for the population mean. The best point estimate for the population mean is always sample mean, which is 16.6. Okay. And now we want to find a 95% confidence interval, and next we will find out the 99% confidence interval. Okay, so let us go to the calculator directly. Here the data is not given, statistic is given. So how do I do that? Is go to the stat and then test, and then go to the G interval, because still sigma is given. Okay, now instead of the data we need to go to the stat and then hit enter. Now what is our sigma? Sigma is 2.8, right? What is our x bar? Is 16.6, right? And what is our confidence? N is how much? 35. So 35 is the N. And go to the what is the confidence interval for the part B? Is 95%. It is already 95 here, so you don't need to enter that, and then hit enter. You get 15.672 and 17.528. Okay, so the interval is 15.672, and then what was the next thing? So the upper limit of the interval is 17.528. 17.528. So again, the same thing can be written as 15.672 is less than the population mean is less than 17.528. What does that mean? This means we are 95% confidence that the population mean falls between 15.672 and 17.528. We are 95% confidence. In other words, another way of describing this is, if you pick sample and find the sample mean, pick another sample and find the sample mean, pick another sample and find the sample mean, and continue that way. So 95% of the time, for 95% of the sample, you get the sample mean between 15.672 and 17.528. This is another way of saying that. Okay. Similarly, let's do 99%. Okay. For 99%, we do exactly the same thing, except we change the confidence level. Okay. Go to the G interval and then change the confidence level to 99. Okay. So what do you get? You change that confidence level to 99. So change that to 9. And then go to the calculate and hit enter. You got 15.381. So it is 15.381. Okay. And then what is the other value? Other value was 17.819. So 17.819. Now from these two here, we wanted to be more confident, right? If you increase the level of confidence, if you increase the confidence level, then you see that this is more wider. Okay, you are getting wider interval. So if you include wider interval, then you are more confident. Okay, that's what we got from here. So if you increase the level of confidence, then the length of the interval, because it starts from 15.6, it starts from 15.3. So it is starting early. So that means the total, and then it ends at 17.5. Here it is ending at 17.8. So it is going further away. Okay, so that means if you increase the confidence level, then the confidence interval will increase. It will go up if you increase the confidence level. Okay, that's what we got from this. So which one is wider? Is 99% confidence interval is wider, right? Percent confidence interval is wider. That's what we get from here. So the next thing we cover on this section is the error term and defining the sample size for specific error. So do you remember that in the when we did the confidence interval formula, we use x bar minus g alpha half sigma over root n, okay, and then comma x bar plus g alpha half times sigma over root n. Sigma over root n. This was the confidence interval formula. Okay, now the term here, this term is called error. Okay, or we call margin of error. So that term is called margin of error. That is, we denote by E equals to G alpha half sigma over root n. Now if you simplify this, how do I simplify? How do I solve for n? I want to solve for n. How do I do that? Is I multiply both sides by root n, and multiply by root n. What do I get? I cancel that. I get root n times E equals to G alpha half times sigma, right? Now divide by E. What do you get? If you divide by E, you will get root n equals to G, that E will cancel out, right? G alpha half times sigma over E. And if you square on both sides, you will get n equals to G alpha half square times sigma square over E square. This is the formula to find out the sample size. Sometimes sample size will be asked and you will have to use this formula to find out the sample size. This is what you get. Since all of these terms have square, you can write a single square outside the parenthesis and write the things inside the parenthesis there. Okay, let us do example here. Consider a population with standard deviation 4.33. So what is given? Sigma is 4.33, that is given. Okay, what sample size should we take? N is asked. N equals to what? To keep the error within 2 units, error is 2. That's what is given. And confidence level is 0.99%. So we need to find out G alpha half based on that 0.99. Okay, so how do I find out that? So the middle area is 0.99. So what is the outside area? The outside area will be 1%, right? Because the 99% is the middle area. So the outside area, the total is 1%, 0.01. And if you divide by 2, you will get 0.005. That's what you will get. So this is 0.005. This is also 0.005, right? So negative G alpha half and positive G alpha half. So how do I find out negative G alpha half? Then is inverse norm and then left area 0.005 and then 0, 1. If you do that, you will get negative 2.58. So basically the G alpha half value will be 2.58. That's how we got that. Okay, now you use the formula there. How do I do that? Is N equals to G alpha half is 2.58 times what is the sigma? Sigma is, we got 4.33 divided by E is 2, and then you just do the whole square, right? So let us do that. You will get basically, we have let me see that 2.58 times 4.33 and then divide by 2, right? 2, you hit enter and then you square that. What do you get? You square, because the square of that, right? Let me square that, and if you square the answer, you will get 31.20. 31.2. So you always round up, because this is the sample size. It is bigger than 31, means the sample size must be 32. That's what you get. Okay, this is how we find out the sample size. Okay, let us do one more example. Okay, so the next example I want to do is example number 8. You guys try example 7 yourself, because everything is given there. Okay, sigma is given, E is given, and then confidence interval is 99%. So as here 99% same confidence interval means G alpha half will be the same value. So G alpha half will be 2.58. You can find out the exactly same way. So what I'm doing is I'm doing example number 8. Let me write down the given things first. So the variance of the water temperature in a lake is 29 degree. So what is that? Variance means, variance is sigma square, right? Sigma square is 29. You need to find out sigma is root under 29. Okay, so let's take the sigma is root under 29. How many days should the researcher select? N equals to what? Sample size is equals to what? Measure the temperature to estimate the mean within 4 degree. So error must be less than 4 degree. So 4 degree. So we will plug in E is equals to 4 degree there. Okay, so the error is, so your estimate must be within 4 degree. That's what the error is, basically 4 degree here. Okay, and then 95% confidence, right? 1 minus alpha is 0.95. Let us find out the G alpha half first. So middle area is 0.95 because the confidence interval is in the middle always. Okay, so what is the outside area then? The outside area will be, so this area plus this area will be 0.05, that is 5%. If you divide, then you will get 0.025. So this is negative G alpha half This is positive G alpha half. So how do I find out negative G alpha half then? Is inverse norm, right? The left area is 0.025. So 0.025 and then 0 and then 1. Okay, if you do that, you will get negative 1.96 in the calculator. Okay, I can show you how to do that. So let us do second verse and then go to the inverse norm and then do 0.025 and then mu is 0, sigma is 1, and then we paste it, you will get negative 1.96. So basically the value of G alpha half is equals to 1.96. So sample size formula, so it is G alpha half square times sigma square divided by E square. You can do a square for each, or you can write a single square outside. Okay, so that will be 1.96 square times sigma square is basically 29, right? Because sigma is root 29, sigma square is 29. So 29 divided by E is 4 square. So if you do that, what do you get? Use calculator. 1.96 square. I did not square 29 because sigma is root 29. Sigma square is 29. That's why I plug in the value of sigma square there. Okay, so it is 1.96 square times 29 divided by 4 square. Okay, that's what we do. If you do that, you will get 6.96. That is 6.96. If you round it, always round off for the sample size. It's 7. So the sample size must be at least 7. If you increase the sample size, then that is better, but at least 7. How did I get at least? Because E is less than 4 degree, right? So E is less than means 1 over E must be greater than. So you can write you know what, in the formula, basically on this formula you can write this way. It doesn't it is more accurate if you write N must be greater or equals to G alpha half times sigma over E square, or that N must be greater or equals to, meaning bigger sample size is okay, but at least 7 sample size is needed to estimate the population mean within 4 degree of the error. All right, guys.